Time period and frequency of oscillation of spring mass system in simple harmonic motion is an important topic. We will discuss some of the key concepts related to this topic and then we will try to solve some of the problems. Consider a light spring of spring constant K and M is the mass which is attached to it. The system is in equilibrium and now if we give a little push to the system will oscillate about equilibrium and the amplitude of the oscillation will be small. The time period of oscillation according to the theory is 2 pi square root of m by k. In some of the questions, if angular frequency is given, then we can calculate the time period using this formula 2 pi by omega. We know for all the periodic motion, the time period is given by 2 pi by omega. But for simple harmonic motion, omega square is equal to k by m. In some of the questions, if force or acceleration is given, then how to calculate the time period? It is like this. In case of simple harmonic motion, the restoring force is given by minus kx, where x is the instantaneous displacement. So from k we calculate omega, from omega we calculate t. Similarly, for simple harmonic motion, this is the instantaneous acceleration. So from omega we can calculate the time period of oscillation. Now, in some of the problems, instead of one spring, there can be multiple springs. In that situation, we have to calculate the time period using the same formula. However, we have to use the effective spring constant. So, in multiple spring cases, if the springs are connected along the same line, okay, maybe vertical line, maybe horizontal line, maybe in other line, but in the same line. For example, these three cases are the cases where all the springs are connected along the same line. But in this case is the case where all the springs are connected in all different direction, right? So when they are connected along the same line, then we can calculate the effective spring constant very easily. It is because the displacement can be added vectorially very easily. So what is series connection? Series connection is the connection where only one end of one of the springs will be connected to the rigid support. And in that situation, the effective spring constant will be 1 by k1 plus 1 by k2. In parallel, however, one end of each spring will be connected to the rigid support. Okay, and in that situation, the effective spring constant will be simply added. Okay, it is the addition of individual spring constant. This logic cannot be applied here. It is because the displacement in all the spring are in the different direction. So we have to calculate first the displacement using vector addition formula and then we have to calculate the effective spring constant.